Let us today understand how to implement stack using linked list. Before understanding stack using linked list, let us first understand what is a stack. Stack is a data structure which follows certain pattern in which the data can be inserted or removed, and it is called as LIFO. Last in, first out, or it is called as FILO. FILO means first in, last out. Both are same, and it has two main operations. One is called as push, and second is called as pop. Suppose this is the stack. When you insert an element, it is called as push, and when you remove an element, it is called as pop, and the operation is always performed on the top. It has two special conditions. One is called as stack overflow. It is called as stack overflow, means stack is full, and second is called as stack underflow, when the stack is empty. So this is about stack. So if you want to see the full source code, you can go to this link, so you will get the full source code. Also, I have given this link in the video description box below, so you can go through this complete code in this site, and can get the complete source code. Let us first try to understand theoretically how to implement a stack using linked list. As you all know that linked list has two fields. One is called as the data field, and second is called as the link field. Data and linked list, and this linked list also has its address. Now, when you want to implement a stack using linked list, suppose this is the stack space. Now, initially the stack is empty. Now, when you want to implement a stack using linked list, while inserting the first element, actually you are inserting a node, and each node is having its data field and the link field. Let the address of this node itself is 1000. As this linked list is empty and this is the first node you are inserting, its link will contain null, and this is the top. So this is the first node in the linked list. Now when you insert a second node into the linked list, suppose this is the data field, this contains D2. Now let the address of this node itself is 2000. Now when you insert a second node into the linked list, its link will contain the address of previous node. Address of previous node is 1000, so this will be 1000. Now this will be the top instead of this one. So the link is like this. Similarly, when you insert a third node, suppose this has the data D3, and suppose this node address itself is 3000. Now this node's link will contain the address of previous node. Address of previous node is 2000, so this will be 2000, and this will be the top instead of this one. So the link is like this. Similarly, when you want to insert the fourth element, and it has the data D4 and the address is suppose 4000. Now this link will contain the address of previous node. Address of previous node is 3000, so this will be 3000. Now this will be the top. So this is called as the push operation. This step, how to implement the pop operation. You have to always pop the element from top to bottom, or you have to remove the element from top to bottom, and it has two steps. First step is make top equals to previous node, and step 2 is delete the node. Now if we have to follow these two steps here, now as you know that this is the top node. Now if you want to do the pop operation, first you have to do on the top node. Before that, first you have to follow this two step. Make top equal to previous node. Now make this as the top, and then you can remove this node. Similarly, you can make this as the top and then remove this node. Similarly, you can make this as the top and remove this node. And you have to always check that stack should not be empty before going to delete, which will be called as the stack underflow. So in this way you can do the pop operation. Let us understand this stack program. Now here, in order to implement a stack using linked list, here I have taken here I have declared a node, linked list node. It has one data field and it has one next field, and it is a type def. Node underscore t is a type def. For it will be easy to declare a structure. For convenient, I have taken here a type def. Now let us suppose node underscore t star of top equal to null. Initially suppose the top equal to null. Now let us understand this push operation. Suppose we want to insert our first node and we call push of 1. When we call push of 1, data equal to 1. Now in this function we are taking a temporary node and we are dynamically allocating the memory. Suppose this given us a node and it returned temp equals to suppose 1000. As you know, it has a data field. So data field, and this is a link field or the next field. Now temp of data equal to data. So data here we are inserting 1. So this will be 1. Now temp of next equal to top. So temp of next equal to top means so this field will be top. Top is now initially null. So this will be null. Now next is top equal to temp. So top, so this will be the top. Now in this way we inserted our first element into the stack using linked list. Now suppose we want to insert our second element and we call push of 2. When we call push of 2, data is here 2. Now here we are again we are taking a temporary variable and we are allocating the memory. Suppose here we have one more node we have taken, and suppose this return us the address as 2000. Now it has one data field and one link field. Now temp of next equal to top. So and before that we have temp of data equal to data. So data will be 2. Next temp of next equal to top. So this is the link field or the next field. So equal to top. Top, as you know that here it is top and it is 1000. So this will be 1000. Now top equal to temp. Now this will be the top. This is not the top now. This is the top. And the connection is like this. So in this way we have inserted our second node into the stack. Suppose we call similarly one more function, one more element. Suppose we want to insert. Now here we are again creating a temporary variable to allocate the node. So here suppose it return the memory as 3000. Now it has one data field and one next field. The temp of data equal to data. So this will be 3. And temp of next equal to top. Top was previously 2000. So temp, this will be 2000. Because this is the temp of next. And the next is top equal to temp. Now top was earlier this one. So now this will be the top. In this way we can insert an element into the stack, and this node contains the address of this node. So this is the way we are creating a stack using linked list. So this is the stack push operation using linked list. Now let us understand the pop operation here. As you know that pop operation always happens from top to bottom, or it is called as last in first out. Now let us call this function pop. As we are popping the element, we need to have the return value of the popped element. array equal to pop. Now when we call this function pop, now see here, I have taken a temporary node having temp equal to null. Now you are checking whether top equal to null. This check is basically to check whether the stack is empty or not, or stack is underflow. Now here, as you can see here, top equal to 5000, which is not empty. Now you are coming to the else condition, because if condition does not satisfy here. So temp equal to top. Now temp will be 5000. Then ret equal to top of data. So ret equals to top of data. Top is 5000. 5000 of data is 5. Then top equal to top of next. Top of next is 4000. So top will be 4000. Now you are freeing the node and making it null. Free of temp. Temp is 5000. So you are freeing it and assigning it null. So top is now this one, and you are returning the return value. Return value is here is 5. So this will be 5. So in this way you have successfully popped the element from the stack. Similarly, let us try to pop the next element. Now ret equals to pop. Now when we call this function temp equal to null, if top equal to null, because as you know that top is 4000 here, which is not equal to top equals to 4000. So if condition does not satisfy, in the else condition temp equal to top, temp equal to top, it will be 4000. Now ret equals to here, ret equals to top of data. 4000 of data is 4. Top equal to top of next. Top of next is 4000 of next. 4000 of next is 3000. So top equals to 3000. Now free temp equal to null. Now we can free this one, make this one equal to top, and you are returning the ret value. So ret equals to 4. So in this way you can pop the element from the stack. So this is the implementation of stack using linked list. Thank you.